Hello, this is the luckiest maths teacher in the world. Today we're going to learn about compound interest. So first I'll explain how this differs from simple interest. Now, because we're all good at maths here, I'll explain it through a graph. So you can see very clearly on the graph, the compound interest, it actually goes up exponentially. The simple interest goes up linearly. What that means is that if you start with any amount and you apply interest to it, it grows a lot faster for compound interest than for simple interest. It's basically because compound interest, we recalculate the interest a lot and we recalculate it on how much is in the account at the time. Whereas simple interest, it's a flat rate. It's going up by the same amount every year. Compound interest is basically like paying interest on the interest. So I'll give you an example to show you the difference numerically. So to illustrate the difference, let's say I invest $5,000 at 10% per annum. Okay, so we'll look at the simple interest first. So it's not too difficult. So 10% of 5,000 is obviously 500. So at the end of year one, you would pay $500 interest. So your investment would now be 5,000 plus $500 interest gives you 5,500. In the second year, again, 10% of 5,000 is 500, so you'd earn another 500. So your investment in total would now be worth 6,000. 5,000 originally plus 1,000 interest. Okay, and you can see the pattern. By the third year, it'd grow to 6,500. But let's look at compound interest. So compound interest, this first year is the same. So after year one, we'd have add 10% of 5,000. So we'd add another 500. So we've got 5,500. Just make the screen a bit smaller so we can see better. All right. So at the end of the first year, it's the same. Now, what happens in the second year? Unlike simple interest, we don't find 10% of the original amount. We find 10% of what we had at the end of the first year. So 10% of 5,500 is $550. So in year two, the amount would now be 6,050. We add 550, not 500. So you can see after 2 years, I've got $50 more. Now let's look at the third year. Again, in simple interest, we just added 10% of 5,000. But what we're doing in compound is we're recalculating and we're looking at what we had at the end of year two. So 10% of 6,050 is obviously $605. So then we add $605. So now I'm $155 more. That's the difference between them, and that explains why compound interest grows a lot more. And because we do the same calculations for investing and borrowing, that means if you borrow money, it grows more. Okay, so let's look at how we actually figure out the compound interest, because great news for you, we're not going to have to do this long way every time. So I'm just going to get rid of what's on the screen now. If you want to copy it down, be my guest. So this is the kind of question that we might do. Invest 5,000, 10% per year, interest compounded annually. How much do I have after 6 years? Now, let's just understand that compounded annually, that's what I was talking about, the recalculations. That means I recalculate the amount in the account every year. I could do it every month or whatever, okay? So here's how we do it. Now you know how to increase by a certain percent. We just times it by 1 plus r over 100. So the amount in the account will be how much you started with times by 1 plus whatever the rate is over 100. That's how we increase something. So after 1 year, I could just go 5,000 times 1 plus 10 over 100. So 5,000 times 1.1, that's what I have at the end of the first year. Now, as you saw in the previous example, to find out how much in the second year, I take the amount in the first year, which is this, and then I increase that by 10%. So again, I times it by 1.1. So that's how much after the second. If I wanted to figure out how much is there after the third year, I'd take that and then times it by 1.1. Now, because of the associative law of multiplication, I can put the brackets wherever I want. So I could rewrite this as 5,000 times 1.1 to the power of 3. If I wanted after 6 years, however, I could go 5,000 times 1.1 times 1.1 times 1.1 times 1.1 times 1.1 times 1.1, or I could notice that I'm increasing it by 10% 6 times. So it will be 5,000 times 1.1 to the power of 6. So just put that on your calculator. I don't expect anyone to do this by hand. To the closest dollar, it's 8858, okay? I just need to make an important point. The formula for simple interest actually gave us I equals, it gave us the interest. This is A equals, so this is the amount I will have. If I was asked to find the interest, I would just use the formula that the interest is the amount you have minus what you started with. So started with $5,000 here, I ended up with 8858. So the amount of interest that I will have earned, if I was asked that, is just 3,858, okay? So because of the way that I've done this, there's a pretty simple formula that I can follow. Again, I'm about to get rid of the stuff on the screen, so if you want to copy it down, please do. So this is the formula for compound interest. A, amount, equals P times, in brackets, 1 plus R over 100 to the power of N. So A, amount, P, principal, how much to start with, R, interest rate, are exactly the same as they were in simple interest. The only thing different is N. N is actually the total number of compounds. It's the number of times that I actually recalculate the interest, okay? Now, as with simple interest, it's really important that N and R are sort of in the same units, okay? So I'll give you an example as to what that means. So this is the kind of question you get. Invest $10,000 at 12% per annum, and the interest is compounded or recalculated half yearly. How much will I have after 4 years? Very simple. Let's use the formula above. So A, that's what we're trying to find, is principal times 1 plus. Now here's the thing. We have to change the rate so it is in line with how often the compounds are. So the rate there, 12% per annum, is per year, but interest is compounded every half yearly. We must change the rate. 12% per year is the same as 6% every half year, okay? If it was 12% per annum, it would be the same as 1% per month. So it's important that we change R, because you won't get that 12% every single time you recalculate. So that's where I got R equals 6 from, okay? Just 12 divided by 2. Now, N is the number of compounds. So interest is compounded half yearly, which means twice per year for 4 years. So obviously the number of compounds, the number of times we recalculate the interest is 4 times 2, 8. Okay? Then we just simply put that on our calculator. So if I put that on my calculator, I get 15,938. Again, I'm rounding to the nearest dollar. I don't care if you round to cents as well. Okay? So it is slightly different from simple interest in that in simple interest we didn't have to change the rate, we just had to change the time. Here you have to make adjustments for R and N. So if the rate is given per annum but interest is not compounded per year, you must change R. Okay, I also wrote in brackets here, so same as compound. You must change R so it's the same as the compound. So if interest is compounded monthly, you must change the rate to months. If interest is compounded every 20 years, you must change the rate to every 20 years. And it's a simple multiplication or division that does that. Usually you'll be dividing the rate. Okay? So, hope you've enjoyed the video. This has been the luckiest maths teacher in the world. Have a great day.